Science is very difficult. On the surface, things seem fairly nice. Have an idea, test it, get results, refine, repeat, and solve all the world's problems. One of the problems, though, is that you don't just have to have the idea. You need to have the ideas needed to test the idea that you have. These are the methods of science, and they're often just as interesting as the ideas themselves. To give a physics-based example, if you think general relativity itself is weird, how on earth do you go about testing it? These are the questions you need to answer if you're going to make progress in science. Often the way experiments are designed can be interesting and beautiful, just as much as the ideas they're made to test. So this is my attempt to bring some of that interest into the world. A series of videos about the more oddball methods in science. But rather than starting with something like general relativity, which even I don't understand, we'll start with stuffed owls on ziplines. So firstly, the idea. A team of researchers from the University of Lausanne in Switzerland are studying barn owls, which vary in colour of plumage. A lot of observations later, they have the following results. I quote from the report written in Nature about their article. The team found that as the moon brightened each month, red owls' hunting success dipped, as did the amount of food, mostly voles, the owls supplied to their chicks. But white owls remained good providers all month long, and hunted best under a full moon. Now, the obvious question is why? They have some inkling that it might be to do with the way light interacts with the white plumage. If this affects their prey in a way which reduces their chance of escape, then that would go some way to explaining this phenomenon. It would also explain why the white owls hunted best under a full moon. So how do you test this? And just imagine you didn't see the title or hear me say owls on ziplines. First off, you might think of maybe observing owls in the wild, but good luck getting clear answers on this. Firstly, you would need to spot the prey the owl was going for before it did, which isn't easy. You would then need to observe the hunt clearly by getting a good view of that prey and the owl in nature. Again, not easy. And you'd need to do this an enormous amount of times to start drawing any conclusive results. So how about trained owls in a controlled hunt? Put the prey in a sealed area and set it up so you can view it clearly. Then get owls of lots of different plumages to fly at it and observe the reaction of the prey. This is a lot better. You now don't have to spot the prey before the owls do because you know where it is. You can just stick it in a box and get the owls to fly over it. However, it still would have some problems. For a start, owls aren't like cuddly puppies or kittens that you keep as pets. They have some relation to their handler that's different to their relation to a random human, but you'd still have a lot of trouble getting them to do exactly what you want in a way that's scientifically repeatable. Even if they do, you're a scientist, you want repeated tests done in a reliable way, so not only do you need the owl to go at the prey, but you need to do that repeatedly and accurately. Not do it a few times, then get tired, give up, or go off to chase a rabbit in a nearby field. This might involve weeks or months of paying for the trained professionals and owls needed, and you're doing experiments on the colour patterns of owls and how they impact prey. You're not getting the big grants here, you need to be a bit stingy. So how can you do without that then? What else can we take off? Well, if we're just testing the owls flying over the prey to see how they react, maybe not use real owls, or use, in the end what they did, taxidermied owls. Stick them on a zipline so that they reliably go over the prey, and then have a look at how the prey respond. This is what they did. They monitored the prey and they found that white plumage made the rodent's freeze time longer. In other words, when they see this massive, great, bright, blinding white plumage of the owl, they freeze up. And this could explain why the white owls could hunt well. It is actually an interesting idea. As the researchers point out, white is rare among nocturnal predators. But also, the method is incredibly interesting. The fact that the researchers were able to check this result is a testament to their ingenuity, and hopefully as I go on in this little series I can share other examples of that ingenuity in all manner of different subjects. Till then, goodbye.